Good day, everybody. Today, on this video, we're going to work on finding the equation of a tangent line and/or a normal line, but using an implicitly defined function that we worked with in the last video, where we were explaining what implicit functions and explicit functions were. So what we're going to do is we're going to take the function, or the implicit curve, x squared plus y squared minus x equals 0, and we're going to find the equation of the tangent line at that point x equals 0.5. But to do so, we're going to need to find dy dx, and in that process, we're going to have to implicitly differentiate, solve for the quantity dy dx, and then find equations of tangent and normal lines. So let's get started. So we write out our original equation, x squared plus y squared minus x equals 0. And we have to, the first step is to use the differential operator d dx on both sides. Because d dx is just like any other operation in math, it's a derivative operation. So we'll do that. We'll take the derivative with respect to x of both sides of the equation. And you can distribute this operator, which is, first of all, it's a new operator to a lot of people, and the fact that we can distribute it is something new as well. So I'm going to take the derivative with respect to x of x squared plus the derivative with respect to x of y squared, and minus the derivative with respect to x of x. And on the right side, I'm just going to have 0. So the derivative of 0 is 0. The left side becomes a simple 2x. The next term becomes, you have to break it out into two parts. It's going to be the derivative with respect to y of y squared times the derivative y with respect to x. And this is what we talked about in the last video, how this is like the I call it a conversion factor, or a unit conversion, because we're making sure that our derivative will be with respect to x, not just with respect to y. So you have to add that term in there, or multiply that term in there. And the last part is going to be just 1, because the derivative with respect to x of x is 1. So let me clean up the equation. So I'll just change the ink so we can see how things have changed. So we have 2x plus, this will be 2y dy dx, and a lot of people, when they write dy dx, they'll write y prime, which is fine with me. I'm just writing it this way to be consistent, and then now I'll just change it over minus 1. It means the same thing as y prime, it's just easier to write y prime. So now you need to do the second step. So the second step is to separate and solve for y prime. So we'll do that. So we'll leave 2y y prime on the left, and we'll move the 1 and the 2x to the other side by addition and subtraction. And now I just need to divide out the 2y. And now I have my equation for my derivative. Now in the problem, it earlier said to find the equation of the tangent line, at the given point. Well, now we're back to the same type of problem we've been working on earlier in calculus, which is, first we want to, basically for a tangent line, use point slope form. And we need an x value, we need a y value, and we need the slope to plug into this equation. So they gave us the x value to be 0.5. We have to go back to the original equation. The original equation was it was x squared plus y squared minus, let me just check what it was. It was minus x equals 0. and we have to use this to solve for y squared. So y squared equals x minus x squared. Y squared equals, we plug in the x value, like in many problems that we've done before. Sometimes you need to plug the x value in to find your y coordinate. And so here we'll put 0.5 in, and 0.5 squared is 0.25. And then, so our y squared value is going to equal, let me just get my calculator. I'm going to pause it so I can, because I'm going to take the square root of 0.25. So I'll be right back. Okay, and our y value is 0.5 also. When you take the square root of 0.25, and it's funny because I just squared it and I got 0.5, I got 0.25, and then when I had y squared equals 0.25, I didn't see right away that this was 0.5, but it is. So my coordinate for my point slope form is going to be 0.5 comma 0.5. So I'll just fill in those blanks. And now I just need to plug in those x and y values into my derivative equation, which my derivative equation from before is it says y prime that I solve for is 1 minus 2x over 2y. So the derivative is going to be 1 minus 2 times 0.5 divided by 2 times 0.5, and that will be 0 over 1, which in this case, look at this, my derivative is 0, and when I plug that in, I end up getting an equation of tangency that is y equals 0.5, and that would mark the location on this graph. I worked out Wolfram alpha to give us a plot, and you can see where our tangent line is at 0.5 comma 0.5. The equation is y equals 0.5. Hopefully this helps. An equation of a normal line in this case would not be too hard to do, because once you know the equation is a horizontal tangent line, you know the normal line would be perpendicular, and that would be x equals positive 0.5, where it crosses through the x-axis. So hopefully this video helps you. My next video, which will be the next part, will work with, as we show in the objectives, it'll work with working with an ellipse that is a slanted ellipse that is not like a circle. It will be on some sort of a slant, and we'll find the equation of, we'll find the normal and the tangent equation to that. So tune in for that one. I hope this was of help to you, and my last video will be finding in this subject, the last video for the subject will be finding a derivative, a second derivative using implicit. Thank you very much, and look forward to your comments.